So lecture 3 is marginal functions. If you print out the handout before yesterday, you may want to, there's going to be some edits to the examples, not to the first few pages, but to the examples. So we have lecture 3, marginal functions. And I basically do a little summary of what was in the book. So I'm not going to go into that because I'm guessing that you guys went through that in the textbook, and instead we're going to just jump to some examples. There is one page that is a little bit new, which is this page, but I'm going to jump to that in the middle of an example and we'll talk about that. So now we're going to jump straight to the examples and talk about these applications while doing some examples. Here we have the average cost in thousands for producing a quantity Q in 10,000s of an item. So in this example, unlike the other examples you've had, I'm actually going to make you think about units as well. The price P in thousands of dollars for producing the quantity Q in 10,000s of dollars is right here. What is the marginal cost when producing 200,000 units? Okay, so marginal cost is what? Does anybody want to remind me what marginal cost is? What's a marginal any function? Marginal implies rate of change. That's right. So marginal cost, we're going to be talking about the rate of change of cost with respect to what? With respect to output. So with respect to how much is made. So in this case, do I have my total cost function here? No, I don't. I don't have my total cost function. I have an average cost function. So we have to look at what the relationship of average cost to total cost is. So if average cost is equal to total cost divided by the total quantity, by this notion, total cost is equal to average cost times quantity. So let's first come up with our total cost equation. And total cost is going to be equal to this equation I have up here, negative 0.01 q squared plus 0.4 q plus 500 divided by q, all times q. So this is going to be negative 0.01 q cubed plus 0.4 q squared plus 500, because 500 divided by q times q is just 500. So now I have total cost. Now I can do the derivative. Marginal cost is going to be the derivative with respect to q of this entire function that we have here. So doing that derivative, I've got negative 0.01 times the derivative of q cubed, which is 3q squared, plus 0.4 times the derivative of q squared, which is 2q. So this is going to give me negative 0.03 q squared plus 0.8 q. And there is your marginal cost function. Now I can determine what the marginal cost is when producing 200,000 units. So to do that, I'm going to substitute q is equal to 200,000. Maybe not. Okay, let's remember that q in our cost equation is in tens of thousands. So what is my q? So for 200,000 units, q is going to be, each q unit is 10,000 units. So I have 200,000 divided by the 10,000. That's right, everybody. It's 20. Nice work. Because each unit of q is 10,000. So I'm looking to do this when q is equal to 20, not when it's 200,000. And then I substitute that into the equation. Move this out of the way. Times 20 squared plus 0.8 times 20. I get marginal cost is equal to 4. Now, what does that mean in terms of units? How would I say that to your employer? How would you say that marginal cost? What are the units on this? So when we're looking at a marginal cost, remember that if this was my cost function, and this is the marginal cost, we're talking about the slope, the derivative here. And when we quantify that derivative, it's saying that the rise over the run is 4:1. So the vertical variable on that graph, let me do that actually in a different color. If this was my cost function, the vertical variable is going to be what? What are the units of the vertical variable? So cost is going to be on the vertical axis, total cost versus quantity. So this is 1 unit of Q, and this is 1 unit of TC. So to do what this is 4/1, really. This is going to be equal to 4 times. Remember, our total cost was in what units? It was in thousands of dollars. And quantity was in 10,000s. So what I'm going to do is I multiply 4 times. This is really 4,000, isn't it? And this is really 1 times 10,000. So what this is telling me is I've got $4,000 for every 10,000 units. My marginal cost is 40 cents per unit. Any questions on those unit conversions in particular, any of it? Yes, you can. So Lanyan is saying, alternatively, can we say that the the marginal cost is equal to $4,000 for every 10,000 units? Absolutely. That is a perfectly okay, that's perfectly correct. Because that's exactly how we got to the 40 cents per unit. Okay, part B. Part B here is about marginal revenue. So what is the marginal revenue when demand is 200,000 units? So here is my price function so that we don't have to look at it again at the top. I made that giant, 1 second. Okay, so there's my price function. So now if I'm looking at revenue, marginal revenue is defined as the change in total revenue with respect to quantity. So this time I'm going to need to come up with my total revenue equation, which is price times quantity. So in this case, I have price of negative 0.05 Q squared plus 2.4 Q plus 300 over Q, all times Q. So my total revenue becomes negative 0.05 times Q cubed plus 2.4 times Q squared plus 300. Now I need to do the derivative of this function to calculate the marginal revenue. So the derivative of this becomes negative 0.05 times 3Q squared plus 2.4 times 2Q plus the derivative of 300, which is 0. This works out to negative 0.15 Q squared plus 4.8 Q. So there I have the equation for my marginal revenue. And what is this going to be when Q is equal, when we have 200,000 units? So that's going to be Q is equal to 20 again. So remember that. So marginal revenue when Q is equal to 20 is going to be equal to negative 0.15 times 20 squared plus 4.8 times 20. And this works out to 36. Giving it the correct units, this time it's saying 36 units of revenue, which are in thousands, over 1 unit of quantity, which is in 10,000s. So multiplying by $1,000 for every 10,000 units, I'll get $3.60 per unit. And that is my marginal revenue. Interpreting this, I would say when demand is 200,000, one expects that for an additional unit of sales, one can have an increase in revenue of $3.60. It is contingent upon where your current demand level is. This would be different if you were starting at 20,000 instead of 200,000, for instance. Okay. Is it advantageous to produce and sell more than 200,000 units? What do you guys think? Why? Advantageous or not advantageous to sell more than 200,000 units? And the answer is yes, it is advantageous. Now let's talk about why, because that's a 50-50, so I usually ask a why. And it's important to support this. Our MR is $3.60 a unit. Our MC is equal to 40 cents a unit. This means at the current level, at this current level of 200,000 units, if you were to sell another unit, you would make $3.60 more in revenue and you would spend only 40 cents more. That means that you would have a profit of $3.20. That's your estimated profit for an additional unit of sales.